I'm going to go ahead and make a quick change to the steps in graphing trig functions of this form, tangent, cotangent. We don't need actually to get the equation into the above form. And saying that, there might be an exception or two, but for right now, all we need to really do is figure out where the function is undefined. That's the first step. All right, so let's figure out where the function is undefined. Well, we know that tangent of x does not exist when x. Okay, so just x. We're not worried about this current function, but the parent function tangent of x, y equals tangent of x, does not exist when x is equal to, when we know that the top of the unit circle, the bottom, and we keep going around, 1 pi over 2, 3 pi over 2, 5 pi over 2, and so forth. Okay, well, what does that mean? Well, that means that whatever you're taking the tangent of is not allowed to be equal to these values. And so we would set, so we say the tangent of 2x minus pi over 2 does not exist when, again, whatever you're taking the tangent of, set it equal to pi over 2. We'll just focus on the positives, but this could also be negative, so plus and minus pi over 2, plus and minus 3 pi over 2. But we're just trying to graph one or two periods of this function, comma, dot, dot, dot. All right, again, we have to solve for x here. And what I want you to consider here is really what we have is we have an infinite number of equations. We have 2x minus pi over 2 is equal to pi over 2. We have 2x minus pi over 2 equals 3 pi over 2. And we have, I'll just do this last one here, equals 5 pi over 2. But then we have dot, dot, dot. It keeps going forever. A convenient way to write all of these equations is just to write it like this. So 2x minus pi over 2 equals one value, another value, another value, and so on and so on. So then what happens is if we add pi over 2 to both sides in solving for x, because that's what we really want. The ultimate goal is to figure out what is x, where are we going to have vertical asymptotes, that's where whatever x is that causes this, what you're taking the tangent of, to be equal to one of these angles. So if we add pi over 2 to all these values, add pi over 2, add pi over 2, and so on, dot, 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 then we're going to get, we're getting closer to having x by itself. Then we get 2x is equal to, what's pi over 2 plus pi over 2? Well, that's pi, 2 pi over 2. 3 pi over 2 plus 1 pi over 2 is 4 pi over 2, which is 2 pi. And then we can start to see the pattern. Then we have 3 pi, and we could even put 4 pi, and so on. Okay, should usually just have 3 dots. And then again, we're dividing both sides, or every term, by 2. So this becomes a very simple algebraic process as long as you go step by step. And now we have our sought after x values, so our real numbers in which the tangent is of this expression here will be undefined. So x is pi over 2, 2 pi over 2, which is pi, 3 pi over 2, and 2 pi. Okay, so we have identified where this tangent function is undefined. And we're going to, let's see, where can I put that? Let's put that right here. And we can put our y-axis here, and we're going to mark off our x-axis every pi over 2 radians. So we're going to go pi over 2, 2 pi over 2, 3 pi over 2. So we will only label where we're going to have a vertical asymptote. So pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2, which is 2 pi. And then we could keep going if we wanted, but we'll just leave it there. And 0 pi over 4, I'm just thinking here, we'll just leave it right there. We'll leave it right there for now. So every pi over 2 radians, and actually we should have put 0 in there, because 0 will also be a vertical asymptote. And how did I know that? Well, this is pi over 2 radians, okay? Pi over 2 radians. And then this is pi over 2 radians. So every pi over 2 radians, we have a new asymptote. Well, if you back up pi over 2 radians, then y, or x equals 0, but also a vertical asymptote. If you don't write that, it's okay. but it's good to know where it's going to start. Okay, now after we mark off the asymptotes, it said draw 3 or 4. I drew 5, and it says plot X intercepts in between the asymptotes. Well, that we also want to make sure we label what those are. Okay, so we want to label where the X intercepts are going to be. So halfway between 0 and pi over 2 is pi over 4, and now we're looking at sectioning off our x-axis every pi over 4 radians. So now pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, and so on. 6 and 7 pi over 4. So we have x-intercepts at each of those values. And this is a tangent graph. So then the last step is to connect the asymptotes with either increasing or decreasing repetitions. And we have intercepts, we have asymptotes, and we have tangent, which means it's an increasing function. Tangent is increasing over every period. And there we have 4 different periods, so 4 repetitions of the tangent function, and there you have it. So it's just kind of one last note. You want to make sure you label the important parts of this graph, and the important parts are the asymptotes and the intercepts. Those are the important parts of the graph. Okay, so there you go.